A very good evening to all the students. I welcome you to my channel, Prof Speaks. This is Dr. Jagrati Mishra. Today, we are going to discuss the concept of measures of central tendency. We'll be taking up mean, median, and mode. So let's get started. We are going to start the concept of measures of central tendency. It refers to the central point around which data values cluster. Say, for example, a class has been asked to write a test and they have been marked out of 100 based on their performance. Now, if most of the students of the class have gotten somewhere between 70 to 75 marks, so that is what the central point of all the values is. There are three primary ways in which the measures of central tendency can be denoted. They are mean, median, and mode. So first I'll come to the concept of mean. Now, mean is often referred to as an average, and it is calculated by adding all the values together and dividing them by the total number of values. This is a very simple definition of mean. Now, let's come to the example. Say, for example, there are 10 children and we are measuring their heights. The example that has been given over here, as you can see, 120, 125, 130, ranging up to 165. So if I have to calculate the mean of this problem, what I'll do is I'll sum all these values. I'll add up all these values. So 120 plus 125 plus 130 plus 135 going up to 165. The total comes to be 1425, 1425. Then we divide them by 10, which is the total number of children, right? So the mean that we are getting here is 142.5, right? Now, the problem with mean is that it is extremely sensitive to extreme values. Say, for example, in a class, there are students, their heights are ranging from 1 to 120 to 135, and there is one student who is like very, very tall. So his height could impact this average a lot. So this is the problem with arithmetic mean. Let's come to the next concept, which is that of the weighted arithmetic mean. Now, in certain cases, all the subjects that have been measured may not have equal weight to assessing a certain phenomena. Say, for example, here, what I have discussed is the marks obtained in various subjects and their weights in ascertaining the percentage or the performance in a particular class. So a student has received various grades in 5 subjects, and each subject has a different weight depending on its importance in the assessment of the particular student. So in maths, the grade that the student got was 85. The weight that is assigned to mathematics is 4. In science, it is the grade obtained as 90 and the weight assigned to the subject is 3. And so on and so forth. As you can see, in English, it's 80 and 2, and in history, it's 75 and 2, and in art, it's 95 and 1. So what would we do here? We will multiply each of these grades by their weights and then calculate their total and divide it further. So here, the first step is multiplying each of the grades by its weight. So 85 into 4 for maths, and then science, English, history, and art. Each of these grades have been multiplied by the weights assigned to the subjects. In the next step, we would add all these weighted values. So we will get 1015. In step 3, we would add the weights. And then in step 4, we would divide the final sum of the weighted values, that is 1015, by the total weight, that is 12. So we get 84.58. So the weighted arithmetic mean in this sum of the student is 84.58. Now we move on to the next concept, that is Median. Median is the central value in a data set. So how do we calculate the median? First, we have to arrange the data, all the values either in ascending order, starting from the lowest to the highest, or in descending order, starting from the highest to the lowest. If the data set has even number of values, then what do? We determine the median by calculating the average of the two middle values. And if the data is odd, things are simpler. We just take up the middle value. So let's see an example for the same. See this data set. So we have 23, 21, 18, 16, 15, 13, 12. And this data has been arranged in descending order. We start from the highest, that is 23, 21, 18, 16. So we can see here is that we have 6 values here and we have 6 values here. So in total, we have 13 values. So 12 would be our middle value. So we have the 7th value, starting from either the, lowest to the highest sequence or from highest to the lowest sequence. What we are getting here is 12. So 12 will be the middle or the median number. Now, let's take an example of data where we have even number of observations. In odd, it was very, very simple. We had just to pick up the middle value and we were sorted. But here we have to now, take up the average of two middle values. So now the observations have again been arranged in descending order from 40, 38, 35, 33, going on to 17, 19 and 17, right? So as you can see in this data, we have 6 values to the left of the middle values, and we have 6 values to the right of middle values. So in total, we have 14 values, which is an even number. So what we are going to do here is we will take the 7th and the 8th value, which is 29 and 27. And we are going to calculate an average out of the same. So 29 plus 27 divided by 2, we get 28. So 28 will be the median for this data set. I hope that's clear. So now let's start with the concept of mode. Mode is a value that appears most frequently within a data set. So any value that is occurring the most number of times in a data set will be considered as a mode. Sometimes the data may contain various modes. So that would be called as a multimodal data. And in some cases, there may not be a mode at all. All values may be unique. So suppose this is a data set that is given in the slide 5, 4, 2, 3, 2, 1, 5, 4, 5. As we can see that 5 is the most frequently occurring number in this data set. So 5 would be considered as the mode. So these were the concepts of mean, median, and mode. This we reached to the end of the presentation. So we'll discuss the concept of measures of dispersion in our next presentation. I'll meet you soon. If you liked the video, please subscribe the channel. Thank you so much.